This video is about deadlock recovery, presented by G. Maunika and Shrihita of 2nd CSCA under the guidance of Dr. Mr. Prasad Sir, PhD, Associate Professor, Department of CSC, SWEC, Bhimavaram. In this video, we'll deeply discuss about deadlock and deadlock characterization and methods for handling deadlocks, deadlock recovery, process termination, advantages of process termination, disadvantages of process termination for process, resource preemption, advantages of resource preemption, disadvantages of resource preemption, resource allocation graph, priority inversion, rollback, and so let's start discussing about these topics briefly.
First, let us discuss about deadlock. All the processes in a system require some resources such as central processing unit, that is CPU, file storage, input-output devices, etc. to execute it. Once the execution is finished, the process releases the resource it was holding. However, when many processes run on a system, they also compete for these resources they require for execution. This may arise a deadlock situation. A deadlock is a situation in which more than one process is blocked because it is holding a resource and also requires some resource that is acquired by some other process. Therefore, none of the process get executed. So let us discuss about the example. Now let us check out the displayed example. Process 1 needs resource 2 and holds resource 1, and process 2 needs resource 1 and holds resource 2. In the above figure, there are two processes and two resources. Process 1 holds resource 1 and needs resource 2, while process 2 holds resource 2 and requires resource 1. This creates a situation of deadlock because none of the two processes can be executed. Since the resources are non-shareable, they can be only used by one process at a time, which means the mutual exclusion. Each process is holding a resource and waiting for other process to release the resource it requires. None of the two processes releases their resources before their execution and creates a circular wait. Therefore, all four conditions are satisfied. Moving on to the next topic, deadlock recovery.
So, it's time for deadlock characterization. So, deadlock can arise if the following four conditions hold simultaneously. 1. Mutual exclusion. 2. Hold and wait. 3. No preemption. And 4. Circular wait. So, let us discuss about them briefly. First one, mutual exclusion. Two or more resources are non-shareable, means only one process can use at a time. Here, in this diagram, we have one resource and one process. So, here, resource 1 is allocated to process 1. So, moving on to the next, hold and wait. A process must be holding at least one resource and waiting to acquire additional resources that are currently being held by other processes. So here we have three resources, namely resource 1, resource 2 and resource 3, and also two processes, process 1 and process 2. Let us discuss about the diagram. Here resource 1 is allocated to process 1 as well as resource 2 is also allocated to process 1, but process 1 requests resource 3 and resource 3 is allocated to process 2. Next, it's time for no preemption. Resources cannot be preempted, that is, a resource can be released only voluntarily by the process holding it. After that, process has completed its task. So, it's time for circular wait. A set P0, P1 and so on until Pn of waiting processes must exist such that P0 is waiting for a resource held by P1 and P1 is waiting for the resource held by P2 and so on until Pn-1 is waiting for a resource held by Pn and Pm Pn is waiting for a resource held by P0. Moving on to the diagram, we have three resources. Those are R1, R2 and R3, and also three processes, namely P1, P2 and P3. So these move in a circular wait. P1 is waiting for P2 to release R2, and R2 is waiting for P3 to release R3, and P3 is waiting for P1 to release R1. So, methods for handling deadlocks. In methods for handling deadlocks, we have four approaches. So, there are four approaches to dealing with deadlocks. One is deadlock prevention, and second one is deadlock avoidance, that is Banker's algorithm, and third one is deadlock detection, and fourth one is deadlock recovery. So, let us discuss about deadlock recovery.
So, moving on to the deadlock recovery. When a detection algorithm determines that a deadlock exists, several alternatives are available. One possibility is to inform the operator that a deadlock has occurred and to let the operator deal with the deadlock manually. Another possibility is to let the system recover from the deadlock automatically. There are two options for breaking a deadlock. Let us discuss about it. One is simply to abort one or more process to break the circular wait, and the other is to preempt some resources from one or more of the deadlocked process. Now, let us discuss about approaches to breaking a deadlock. Now, let us see the above displayed diagram. Recovery from deadlock is divided into two: process and resources, and also the process is further divided into two. One is abort one process at a time until the elimination of the deadlock cycle, and the next one abort all deadlock process. And now coming to the resources, it is preemption and rollback. Coming on to the process termination. To eliminate deadlocks by aborting a process, we use one of the two methods. First one is abort all the deadlock process, and the next one is abort one process at a time until the deadlock cycle is eliminated. Now, let us discuss about abort all deadlocked processes. This contains a method clearly will break the deadlock cycle, but at great expense. The deadlocked process may have computed for a long time, and the results of these partial computations must be discarded and probably will have to be recomputed later. This approach is not suggestible but can be used if the problem becomes very serious. Moving on to the next one, abort one process at a time until the deadlock cycle is eliminated, contains. This method incurs considerable overhead, since after each process is aborted, a deadlock detection algorithm must have invoked to determine whether a processes are still deadlocked. Till now, we discussed about the meaning of the process termination. Now, moving on to the advantages of process termination, it is a simple method for breaking deadlock. It ensures that deadlock will be resolved quickly as all the processes involved in the deadlock are terminated simultaneously. It frees up resources that were being used by the deadlocked process that make those resources available for the other processes. Now, let us discuss about the disadvantages of process termination. It can result in the loss of data and other resources that were being used by the terminated process. It may cause further problems in the system if the terminated process were critical to the system operation. It may result in a waste of resources as the terminated process may have already completed a significant amount of work before the process being terminated. Now, let us discuss about for process. This includes two. One is destroy a process and second is end all processes. Now, let us discuss about destroy a process. Although killing a process can solve our problem, choosing which process to kill is most important. The operating system typically terminates a process after it has completed the least amount of work. And moving on to the next one, which is end all processes. Although not suggestible, this strategy can be used if this issue worsens significantly, because each process will have to start from scratch after being killed. The system will become inefficient. Moving on to the next one, resource preemption. Preempt some resources from deadlocked process and give these resources to other processes until the deadlock cycle is broken. If preemption is required to deal with deadlocks, then three issues need to be addressed. One is selecting a victim, and second one is rollback, and the third is starvation. As discussed previous, now let us discuss a detailed about selecting a victim. Now, this includes the strategy. So, selecting a victim includes the strategy involves selecting one of the processes involved in the deadlock and aborting it, allowing the remaining process to be proceed. The selection criteria can be based on a variety of factors such as process priority, resource usage, or time spent waiting. Now, rollback. Rollback involves undoing the work done by a process up to a certain point in time to allow other processes to proceed. This can involve rolling back database transactions or undoing changes made by a program. So the last one is starvation. Starvation occurs when a process is continuously denied access to a resource it needs to proceed. This technique involves forcing one of the processes involved in the deadlock to release the resources it is holding. This can be done by increasing the priority of other processes that are waiting for the same resources, or by introducing a timeout that will cause the process to release the resources after a certain amount of time. So, as we discussed about the resource preemption, it is time for the advantages of resource preemption. It can help in breaking a deadlock without terminating any process, thus preserving data and resources. It is more efficient than process termination, as it targets only the resources that are causing the deadlock. It can potentially avoid the need for restarting the system. So, in the previous slide, we discussed about the advantages of resource preemption. Now, in this slide, we are going to discuss about the disadvantages of resource preemption. It may lead to increased overhead due to the need of determining which resources and processes should be preempted. It may cause further problems if the preempted resources were critical to the system operations. It may cause delays in the completion of processes if resources are frequently preempted. Now, it's time for resource allocation graph, RAG. The resource allocation graph is a popular technique for computer system deadlock detection. The RAG is a visual representation of the process holding the resources and their current state of allocation. The resources and the process are represented by the graph nodes, while their allocation relationships are shown by graph edges. A cycle in the graph of the RAG method denotes the presence of deadlock when a cycle is discovered. At least one resource needed by other process in the cycle is being held by each process in the cycle, causing a deadlock. The resource allocation graph method is a crucial tool in contemporary operating systems due to its high efficiency and ability to spot deadlocks quickly. So, in the displayed diagram, we have two resources, namely R1 and R2, and also two processes, P1 and P3. P1 is holding a resource R1 and P1 wants resource R2. P3 is holding a resource R1, R2 is allocated to P3. Moving on to the next topic, priority inversion. A technique for breaking deadlocks in real time systems is called priority inversion. This approach alters the order of the process to prevent stalemates. A higher priority is given to the process that already has needed resources, and a lower priority is given to the process that is still awaiting them. The inversion of priorities that can result from this approach can impair system performance and cause performance issues. Additionally, because higher priority processes may continue to take precedence over low priority process, this approach may starve low priority processes of resources.
It's time for rollback. In database systems, rolling back is a common technique for breaking deadlocks. When using this technique, the system reverses the transactions of the involved process to a time before the deadlock. The system must keep a log of all transactions and the system's conditions at various points in time in order to use this method. The transactions can be rolled back to the initial state and executed again by the system. This approach may result in significant delays in the transactions, execution, and data loss. This is Deadlock Recovery. Thank you.